Dr. Muthuvel, sir.
Yes, sir.
Yeah. How is the climate there in Chennai?
Pardon? I can't understand, sir.
How is the climate there in Chennai?
Chennai climate, sir.
Yeah.
Now the temperature is raised, sir. 33, 34, sir.
Okay.
Just like the summer is will come, sir. Gradually rise the temperature. In our area is a rural area, sir. We are away from Chennai, nearly 300 kilometers, sir.
Okay. Dr. Gatwe, sir. Aparna, ma'am.
Yes, sir. I'm here.
Yeah, I think Dr. D.I. Share, sir, has joined. Dr. Suman Deshpande, sir, also has joined. So, I think we must start the program now.
Okay. Okay, sir. Shall I start now?
Yeah, because yes. Let me confirm, Dr. Shahari, sir, has joined or not?
Okay, you can confirm first and then we will start.
खाटवे सर सब लोग ज्वाइन हो गए क्या?
हाँ सर, हाँ कार्य सर भी है, देशपांडे सर देखता हूँ, हाँ देशपांडे सर भी ज्वाइन.
खाटवे सर, your voice is not that much clear. It is not.
सर अभी क्लियर है? सर अभी क्लियर है आवाज? सर अभी वॉइस क्लियर है?
Clear
Yes,
है,
sir,
थोड़ा
voice is
कम
clear.
My voice is clear or not, sir?
Yes, sir, your voice is clear and loud. Okay, आता ठीक है sir?
Okay, is it clear, sir, my voice?
Yes, sir, your voice
yes.
is clear.
Doctor,
And loud also.
Aparna ma'am, you can start now program.
Okay, sir. A very warm good morning to one and all. I welcome you all to this online guest lecture on nanocomposites for environmental remediation as a part of National Science Day celebration 2022, jointly organized by Science Forum, Parent Teacher Association, and under the aegis of DBT Star College Scheme, J.M. Patel Arts, Commerce and Science College, Bhandara of Gondia Education Societies. Today, we are honored to have with us an eminent resource person, Dr. R. Muthuvel, Assistant Professor, Department of Chemistry, Annamalai University, Annamalai Nagar, Tamil Nadu, India, and Chairperson of today's program, Dr. Vikas Domne, sir, Principal, J.M. Patel Arts, Commerce and Science College, Bhandara. Due to some health issue, sir is not available today. I also welcome Dr. D.I. Shahare sir, Head Department of Physics, Dr. Karthik Panikar sir, IQAC Coordinator and Dean Administration of the College, Dr. Sumant Deshpande sir, Coordinator, Parent Teacher Association, Dr. Shyam Dafre sir, Coordinator, DBT Star College Scheme, Dr. Ajay Ghatode sir, Coordinator, Science Forum, Head of the departments, faculty members, and my dear students, once again, I welcome you all. Now, I invite Dr. Ajay Ghatode sir, Coordinator, Science Forum, to give introductory remarks. Ajay Ghatode sir, please.
Thank you, ma'am. Thank you very much. Very good morning to one and all. On behalf of organizing committee and being a coordinator of Science Forum, myself, Dr. Ajay Ghatode, Assistant Professor in Chemistry, Jem Patel College, Bhandara, welcome you all for today's guest lecture, which is organized on the occasion of Science Day. Today, we have with us a distinguished guest. It is my pleasure to welcome a very respected principal sir of our college, Dr. Vikas Dhomne sir. Today's resource person, Dr. I. Muthuvel sir, a guest lecture for today's guest lecture for today's Science Day. Professor Sumant Deshpande sir, Coordinator Parents Teachers Association, Dr. D.I. Sahare sir, Jem Patel College, Bhandara, Dr. Karthik Panikar sir, IQAC Coordinator, Jem Patel College, Bhandara, Dr. Shyam Dafre sir, Head and Coordinator, DBT Star College Scheme, all the heads of the respective departments, staff, and my dear students. Every year, National Science Day celebrated on 28th February. The first National Science Day was celebrated on February 28, 1987. This day recalls the notable invention, that is Raman effect, by India's great scientist Dr. Sir C.V. Raman. He was awarded the Nobel Prize for his discovery. Since that day, February 28 is being celebrated as National Science Day to recall the great discovery of C.V. Raman. Now, I want to focus the importance of Science Day in our life. Our lives are in a culture where we may see two kinds of individual. Any set of people who follows a religious journey and hold beliefs about science. From other side, there are some who through achieving new heights in scientific and technological. People believing in technological miracle prefer to honor National Science Day in the same manner they prefer to observe their culture and religious observation. Science pushes us to our limit. Everything in our environment is based on science. The National Science Day is for those who believe in science, scientists, and next generation of scientists and technologists, and those who are fascinated by scientific discoveries. National Science Day is marked to raise awareness about the importance of science in people's daily lives, to recognize all the activities, projects, and achievements in the field of technology that help humanity. It is honored by implementing new technology for scientific growth, providing opportunities for scientifically inclined individuals in India, and encouraging and popularizing technology and science. Now, I want to highlight the purpose of the celebrating science. The basic objective of National Science Day is to spread the message of importance of science and its application among the people. National Science Day is celebrated as one of the main science festivals in India every year with the purpose. I like to mention some purposes. The one is to widely spread a message about the significance of scientific application in the daily life of people. Another one, to display all the activities, efforts, and achievements in the field of science for welfare of human beings. Next, to discuss all the issues and implement new technology for development of give an opportunity to the scientific minded citizen in the country. And last, by my knowledge, to encourage the people as well as popularize the science and technology. Each year, Science Day has a theme. In the last year, the theme for National Science Day was Future of STI. STI stands for Science, Technology and Innovation. Impact on education, skill and work. This suggests that science must have a beneficial effect on education and that learners must be more interested in science and innovation. The topic was chosen to encourage greater knowledge of present scientific problems and also the implications of studies on learning, aptitude, and profession. Each year, the theme of such days are varied, highlighting a particular aspect of nation's society. The theme are intended to recognize the contribution of common people, students, employees, popular officials,
Yeah, there may be some problem due to power cut off. Dr. Aparna?
Yes, sir. Yes, sir.
I think there is maybe the problem in due to power cut off.
Okay, sir. Shall I proceed further?
Yeah, there is a power outage. I suppose there is a power outage. Professor, there is a power outage. We'll ask him to start the generator. Just wait for a couple of minutes. Just wait for a couple of minutes.
Okay, sir, no problem. We will wait for some time.
I'm online, sir.
Okay. Now, if you can continue the stream, there is no problem. Is Muthuvel sir still with us? No, is Muthuvel sir still with us?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Then you can proceed. Professor, if you have power in the science building, you can proceed.
No, but power, there is no power in science building, also, but you can, the Gateway can continue because he's having some backup with his machine.
Yes, sir. I have the backup. I have connected to my phone.
Continue,
Okay, shall I continue? Okay, sir. Okay. Each year, science has a theme. In the last year, the theme for National Science Day was Future of STI. STI stands for Science, Technology and Innovation. Impact on education, skill and work. This suggests that science must have a beneficial effect on education and that learners must be more interested in science and innovation. The topic was chosen to encourage greater knowledge of the present scientific problems and also the implication of studies on learning, aptitude, and profession. Each year, the theme of such days are varied, highlighting a particular aspect of nation's society. The theme are intended to recognize the contribution of common people, students, employees, popular officials, and perspective from a major scientific institution. The theme for National Science Day 2022 is Integrated Approach in Science and Technology for Sustainable Future. Every year, J.M. Patel College, Bhandara, under a science forum, celebrates the Science Day by arranging lots of activities. This year, we have also conducted quiz, debate, essay competition, poster competition, webinar, seminar presentation, and many more. To continue with this, today's guest lecture. Through this platform, I express my thanks to each faculty who directly or indirectly make the events successful. Thank you, everyone. This event honors Sir C.V. Raman, outstanding contribution to research and discovery of providing hope and inspiration to future generations to pursue their goals. To not enter only the single breakthrough in any area, but to continue hunting the nation's credits in every way possible. We celebrate National Science Day to recognize science grandeur with the goal of eruditing taboos and accepting that environment is mostly about science, as scientific research is mostly about environment. In whichever way fits, you fit taste. My last word for this occasion: it's a waste of time to live without science. No miracle happens, it would be a separate issue, but if you believe in science, you will always consider the logic behind the decision. We have been fortunate enough to see some amazing scientific study, breakthroughs, and technology. By this word, I, Dr. Ajay Ghatole, Science Forum Coordinator, conclude here. Thank you. Thank you.
Thank you, sir.
For the further proceeding, I hand over the mic to Dr. Aparna Yadav.
Thank you, sir. I invite Dr. Sumant Deshpande, sir, Coordinator, Parent Teacher Association, to give concept note.
धन्यवाद अपर्णा मॅम. आज राष्ट्रीय विज्ञान दिवस त्या निमित्ताने आलेल्या सर्व पाहुण्यांना आणि या कार्यक्रमाला उपस्थित असलेल्या सर्वांना शुभेच्छा आणि नमस्कार. राष्ट्रीय विज्ञान दिवस 28 फेब्रुवारीला साजरा केला जातो. त्या निमित्ताने आज उपलब्ध झालेले डॉक्टर आय मुथुवेल, त्याचप्रमाणे आमच्या महाविद्यालयाचे प्राचार्य डॉक्टर विकास धोगणे सर, या कार्यक्रमाचे समन्वयक डॉक्टर श्याम डफळे सर, डॉक्टर अजय घाटोळे, डॉक्टर डी आय शहारे, डॉक्टर कार्तिक पनिक्कर, तसेच उपस्थित सर्व विद्यार्थी, पालक, प्राध्यापक आणि बंधू. विज्ञान दिवसाच्या शुभेच्छा देतानाच मला आणखी एक शुभेच्छा द्यायची आहे. कालच मराठी राजभाषा दिवस संपन्न झाला. कविवर्य कुसुमाग्रज यांची जयंती मराठी दिन म्हणून साजरा केली जाते. त्या मराठी दिनाच्याही सर्वांना शुभेच्छा. JM पटेल महाविद्यालयामध्ये विज्ञान दिवस दरवर्षीच अतिशय उत्साहाने आणि नव्या नव्या संकल्पनांनी साजरा केला जातो. या उपक्रमामध्ये मान्यवरांची व्याख्यानं, तद्वत अनेक स्पर्धाही आयोजित केल्या जातात. आमच्या महाविद्यालयामध्ये शिक्षक पालक संघ अस्तित्वात आहे आणि शिक्षक पालक संघाच्या वतीने विविध उपक्रम महाविद्यालयात साजरे केले जातात. त्यामध्ये शिक्षक पालक सभा, त्यामध्ये पालकांच्या अपेक्षा, पालकांचे प्रस्ताव, त्यांच्या सूचना या सगळ्यांचं स्वागत केलं जातं. शक्य तितक्या सोयी सवलती, शैक्षणिक साधनं आणि इतर सर्व सुविधा या माध्यमातून उपलब्ध करून दिल्या जातात. शिक्षक पालक संघ हे एक व्यासपीठ आहे, ज्या व्यासपीठाच्या माध्यमातून महाविद्यालयाचं प्रशासन, महाविद्यालयाचे प्राध्यापक, कर्मचारीगण आणि पालक, विद्यार्थी या सगळ्यांमध्ये एक संवाद निर्माण व्हावा यासाठी हा प्रयत्न असतो. जशा विद्यार्थ्यांना सोयी सवलती उपलब्ध करून दिल्या जातात, त्यांच्या समस्यांचं निवारण करण्याची ही जबाबदारी शिक्षक पालक संघ घेते आहे. त्याचबरोबर विद्यार्थ्यांसाठी नवे नवे उपक्रम राबविण्याचाही मानस शिक्षक पालक संघाचा असतो. आजचं हे व्याख्यान आणि आजचा हा वेबिनार हा त्याच उपक्रमाचा एक भाग आहे. याशिवाय ग्रंथालय आणि इतर बाबीतही शिक्षक पालक संघ अग्रणी असतो. आमचे प्राचार्य शिक्षक पालक संघाचे सन्माननीय अध्यक्ष आहेत. ते वेळोवेळी या शिक्षक पालक संघाला सर्वतोपरी मदत करत असतात आणि त्याचबरोबर कॉलेज परिपूर्ण व्हावं विद्यार्थ्यांना कुठल्याही त्यांच्या अडचणी निर्माण होऊ नयेत या दृष्टीने त्यांचा प्रयत्न सातत्याने असतो. मी आजच्या विज्ञान दिवसाच्या पुनश्च एक बार शुभेच्छा देतो. सर्वांचं मनपूर्वक स्वागत करतो आणि शिक्षक पालक संघाची भूमिका या ठिकाणी मांडण्यासाठी संधी दिल्याबद्दल आयोजकांचेही धन्यवाद देतो. पुनश्च एक बार विज्ञान दिवसाच्या शुभेच्छा आणि धन्यवाद.
Thank you very much, sir.
अपर्णा मॅडम.
Thank you very much, sir. Now I request Dr. D.I. Shahare, sir, Head Department of Physics, for the welcome address. Dr. D.I. Shahare, sir.
Hello. Can you hear me?
Yes, sir.
Hello.
Please continue, but you are not visible properly.
Good morning to you all.
Shahare sir, your video is not clear. I mean, you'll have to put down the mobile slightly. Shahare sir, थोड़ा मोबाइल आपके तरफ खींचिए. पंखा दिख रहा है, आप नहीं दिख रहे. Yeah, now it's okay.
Good morning to you all, and hearty greetings for the National Science Day. Today's resource person, Dr. Shyam Dapre, Aparna Madam, Dr. Ghatole sir, Dr. Karthik Panikar, Suman Deshpande sir, and all the participants. Today we celebrate National Science Day to remember Sir C.V. Raman for his discovery of Raman effect. The Raman effect is nothing but when the light is passes through the transparent organic compound, then it scatters, and in the scattered light, two wavelengths are there. One is a wavelength of incident light and other is one modified wavelength. This effect is very well known. It is used in very scientific research and Raman spectroscopy also. For this discovery of Raman effect, Sir had got the Nobel Prize for his discovery. On this occasion, we celebrate the National Science Day to promote the scientific temper among all the citizens of India and to popularize the science among the science faculty members. So, I wish all the success, all the best for this occasion, and I conclude here. Thank you so much.
Thank you, sir, for sharing your valuable guidance with us. Thank you very much. Now, it is my proud privilege to introduce today's resource person, Dr. I. Muthuvel, Assistant Professor, Department of Chemistry, Annamalai University, Annamalai Nagar, Tamil Nadu, India. He did his PhD in chemistry in the year 2011. He has 15 years of experience in teaching. Presently, his areas of interest in research is green chemical synthesis of various solar light active catalyst, synthesis of coupled semiconductor materials for photocatalytic applications, and many more. He has published 58 research publications in the reputed national and international journals, and he guided successfully 2 PhD aspirants. Sir has successfully completed 1 UGC major research project. He is the reviewer of many reputed journals such as Springer and elsewhere. Sir is one of the finest researchers in the field of chemistry. Now I invite you, sir, to deliver the presentation on nanocomposites for environmental remediation and guide our students. Sir, please.
Thank you, madam. Thank you for your nice introduction. Good morning, one and all present here. I would like to thank all the dignitaries, and especially my friend Ajay sir, giving the opportunity for presenting my research work in your college. And now the physics professor told that this is the National Day, National Science Day celebrations. So we have to remember the Roman effect. Everything is there. Now I will present my research work. Just a minute. I will share my PPT.
तिकडे ऑफिस मधून पहिले कोणत्या ग्रुपला विषयांचा तर मॅथमॅटिक्स आणि केमिस्ट्रीचे एक ऍप्लिकेशन बनव.
Is it clear, sir? Is it visible?
It is visible and clear.
Yeah. Visible.
Okay. Nanocomposites for environmental remediation is the topic. Not only for nanocomposites, nanomaterials also, it will be used for that environmental remediation and some other purposes. So already we know that very much in nano. What is nano? Nano is useful for many applications: chemistry, biology, engineering, medicine, environment, and energy, and physics also. It will be useful. Fundamentally, what is nanotechnology? Nanotechnology is the creation of functional material devices and systems through training and control of matter at a dimension in the nanometer scale length 1 to 100 nanometer, where new functionalities and properties of matters are observed and harnessed for a broad range of applications. Nanoscience and nanotechnology concerns objects that are extremely small. Okay. So the nanotechnology is the acting of manipulating materials at very tiny scales at a level of atoms and molecules with the materials under nanometers, already 100 nanometers. Already I told that the normal rules of physics and chemistry no longer apply, and many materials start to display unique and sometimes surprising properties. They may become very much stronger, more conductive and reactive. For example, solid like gold turn into liquids at room temperature, and silver takes on antimicrobial properties. Inert materials like platinum and gold becomes a catalyst, and stable materials like aluminum become combustible materials. These new properties have opened up exciting field of study and applications. Nanoscience is the study and discovery of these new properties. Nanotechnology is the use of these new properties in special products and applications. So nanotechnology is already benefiting areas such as the healthcare, environmental, energy, and national security, and precision targeting of cancer cells deep within the body, removing pollutants from groundwater and soil, enhancing performance of solar panels, improving detection of chemical and biological weapons, and preventing infection in wounds are just a few of ways nanotechnology is enhancing our world. Some of the applications already we have discussed: electronics, energy devices, high-strength materials, super sensitive nanosensors, and ideal for catalytic support. Some of the drug deliveries for delivery of TB, HIV, and malaria drugs are used in biosensors, which can be used to pinpoint disease in the body, solar cells and flat panel displays and special coatings. Aeronautics and automobile industries, scratch resistant coatings, self-cleaning windows, fuel cells, coatings, composites, medicines, silicon nanoparticles can be used for printing electronics. Evolution of nanotechnology. So 2000 years ago, sulfide nanocrystals used in Greek and Roman to dye hairs. Hair dye can be used as a hair dye. So 1,000 years ago, in the Middle Ages, golden nanoparticles of different sizes are used to produce different colors in stained glass windows. So this is the golden nanoparticle coated paints there. It was painted nearly 1,000 years ago. 1959, the first theoretical physicist, Richard Feynman, envisioned by the there is a plenty of room at the bottom. He gave a line for that. There is a plenty of room at the bottom. He's a theoretical quantum physicist. In 1974, nanotechnology, Tankus uses a term nanotechnology is the first time. And in 1981, IBM developed scanning tunneling microscope. 1985, buckyballs, scientists at Rice University and the University of Sussex, discovered C60. 1986, Engines of Creation, first book of nanotechnology by Eric Drexler. Atomic force microscope invented by Benning, Quad, and Grib. 1989, IBM logo made with individual atoms. Already I have gave you photography. And 1991, carbon discovered by Lijima. And 1999, Nanomedicine is the first nanomedicine book by Fitas. 2000, Nanotechnologies Initiative is launched. From the ancient times, this is the Damascus sword. It is 17 AC. It is having a carbon nanotubes. This is having a nanotubes. This sword can be analyzed. The carbon nanotubes is coated that surface of the material. And similarly, Tipu sword also. Tipu Sultan is the king of Mysore, Karnataka. He having the same carbon nanotube materials are coated on that stainless steel. So the Catholic. Just a minute, my internet is unstable. Once again. Okay. Is it clear? My voice is clear?
Yes, sir, it is clear.
Okay. Kathai Cathedral windows is 6th and 15th AD. This is the gold nanoparticle coated paint is there. This is the, and cups are there. Oh, is nanotechnology is really new. Lycurgus cup is the 4th century AD. It is presently now in British Museum in London. Gold and silver nanoparticles, nearly 70 nanometer in 14:1 ratio. So when we pass the light, the polarization of reflected and transmitted light. Okay. The colors originate from metal nanoparticles embedded in the glass at places where light is transmitted through the glass. It appears red. At places where light is scattered near the surface, the scattered light appears greenish color. Just a minute. Nanomedicine is a injectable nanomedicine, yeah, tiny nano machines in our body. It will cure cancer cells. So it will be injected in our blood vessels. So it will be traveled in the serum. Then it will be cure the targeted cancer cells. We know that already 2.0 cinema is there. Cinema industry creating a microbots in the version of 3.0. The injectable nanobots are now is a growing medicinal field in India and all other countries. It will be cure cancer cells and some of the highly problematic parts in there. Yes, this is the different suspensions, diameters of that gold nanoparticles. The suspensions of spherical gold nanoparticles with various diameters 150, 100, 80, 60, 40, 20 nanometer from left to right in the water. The difference in color due to the different scattering and absorption behavior of small and large gold nanoparticles. So simple chemical reactions for preparation of gold nanoparticles. So we have to use a gold source. We have to add a reducing agent. We get a gold nanoparticle. Similarly, silver nitrate can be used as a silver source, and we have to add a reducing agent. We get a silver nanoparticles. Some of the reducing agents, sodium borohydrate, citrate, alcohols, are used for reduction purposes. Stabilizing agents or some of the surfactants and polymers can be used for that preparation of that gold and silver nanoparticles. Yeah. This is the well divided metallic state of gold. So these liquids are first examples of metallic gold nanoparticles, colloids, gold colloids. They were made accidentally by Michael Faraday, whilst he was mounted thin sheets of gold leaf onto the microscope slides. Faraday spent a significant amount of time in the 1850s investigating the properties of light and matter. He made several hundred gold slides and examined them by shining light through them. The colloids are on display at his original laboratory, the ground for Royal Institution in the Faraday Museum. It is available. This gold, divided gold, metallic gold is present in the Royal Institute in the library. Yeah, simply we have to make a nanoparticle. So we have to add 10 milligram of chloride, and we have to add 95 ml of water in a hot plate with continuous stirring. During the heating, we have to add a little amount of citrate, that is citric acid. We have to add. It will reduces gold nanoparticles. Already botany people and some of biotechnology peoples are doing that the biosynthesis of nanoparticles. So they take any one of that leaves for they have to reduce that iron nanoparticles, silver nanoparticles, and then take antibacterial activity, which is routinable work for that. Nowadays, all the people's doing that this type of simple and efficient method of nanoparticle generation. It will be economic also. In here, this plant is there. I don't know exactly. This plant is there, plant leaf, and we have to add ferrous sulfate and leaf extract for the desired composition. So we have to 2:1 composition. Then we have iron oxide nanoparticles. The iron oxide nanoparticle can be further characterized by XODFT or SIM, UV visible spectroscopy, and EDX also. Then finally, it will be used for antimicrobial activity, and usually iron oxides can be used as cancer activity also is there. Excellent cancer activity as there. So we have to take cancer activity also. In my topic, this is environmental remediation by nanomaterials. Pollution of water by dye industrial effluent is a serious problem in the developing countries. Removal of dyes from wastewater is a challenge to the industry because the synthetic dyes are stable and difficult to destroy by common treatment methods. This is the industrial effluents, and common treatment methods for that. Just a minute. Yeah. Is it full screen or Ajay sir?
Yeah, sir.
Is it clear, sir?
Yes, sir, it is clear, sir.
Is it clear?
Okay, sir. Two types of treatments are already used in the industry. So those concentrate the pollutants into sludge. That is adsorption, precipitation, and membrane filtration. These are the first two methods. Second one, those which completely mineralize the pollutants, biodegradation, advanced aggregation process, and this advanced aggregation process is a economic and green technological process. Some of the disadvantages for that biodegradation, some of the organic waste are toxic to the microbes. So microbes are, some of the microbes degrade that cyanides and dye molecules are there. Some organic waste are more toxic to the microbes. So environmentally friendly is present is very important. Without that environmentally friendly microbes, the complex organic compounds are not easily biodegradable. Some of the complex organic compounds are not biodegradable. Microbes cannot withstand high pollutant concentration. So we have a high pollution concentration. The microbes cannot withstand high pollution concentration. So can you please? I have to stop my video, okay? Because my internet is not good.
Yes, sir. And one other thing, sir.
Okay,
take
sir.
a
Okay.
slide.
I have my stop my video, sir. Okay. Next one. Advanced aggregation process.
Sir, one thing. Can you please make the slide as a presentation mode? That is a full screen mode.
Yeah. Is it full screen, sir?
No, it is not full screen now.
Yes, sir. Is it full screen?
Yes. Now it is.
Okay.
Continue.
Oh, okay, sir. Yeah. Advanced aggregation process. Advanced aggregation process refers to the process in which the highly reactive hydroxy radicals, which are used for degradation of pollutants. Pollutants such as dyes, pesticides, and pharmaceutical effluents, and all we have to degrade effectively. Semiconductor photocatalysis, we can use solar light and UV light. In the presence of UV light, we have only do the experiment in the bench scale. But in the solar light, we have used bench scale as well as the pilot scale also we have to do that. And UV H2O2 process, it will be only for solar light. And IN2, IN3 H2O2 photophantom process, solar and UV light can be used. Ozonation process can be used UV and solar process. Ozone H2O2 process can be also used UV and solar process. Just a minute. My slide is not moving. Just a minute. Hello.
Hello, sir.
Oh, my slide is not moving. Just a minute, sir.
Okay. I think the internet.
Yeah, I think the network problem is there. Yeah, again I have to stop sharing. I will keep sharing there. Is it visible, sir?
Yes. It is visible to us. Just make a full screen.
Okay, sir. Okay, sir. Just a minute, sir. Yes. The slide is moving, sir. Is it clear, sir?
It is clear.
Yes.
Now the slide is advantages on photocatalysis.
Okay, advantages. Oh, okay, sir. Shall I continue, sir?
Okay, you can.
Advantages of photocatalysis. So complete metallization, no waste disposal problem, no expensive accidents needed, low cost, only mild temperature and pressures are necessary, easy to operate these processes. So some of the common semiconductors which having the band gaps and absorption wavelengths are there. So photocatalysis is one of the most prominent and widely used process in the elimination of organic pollutants because it is a clean technology in the water system treatment, and the final decomposition product of organic compounds can only be carbon dioxide and water. So advanced aggregation technologies involve the in situ generation of highly potent chemical accidents such as hydroxy radicals. So the photocatalytic efficiency of TiO2 alone is generally very low. So this is primarily attributed to its wide band gap. Because of that, approximately 3.2 electron volt. So it can only absorb UV light, which occupies about 4% in the solar light. This is the general TiO2 mechanism is there. When we pass the light, UV light, the semiconductors TiO2 having a valence band and a conduction band. So when we pass the light, the valence band electron will move to conduction band. So the hole is created in the valence band. The hole is reactive with the water molecule to create hydroxy radical. The conduction band electron can be reactive with oxygen to produce superoxide radical anion. The superoxide radical anion and hydroxy radical is the major source to degrade the organic pollutant to carbon dioxide and water. So again, I have to discuss that. So when we pass the light, the valence bond electron can be ejected to conduction band. The valence band having a hole is there. So it will be creating a hole. The hole react with water molecule to produce hydroxy radical in the presence of light. The conduction band electron react with the oxygen molecule to produce superoxide radical anion. The superoxide radical and the radical anion and hydroxy radical, the major source to degrade the pollutants. So usually the zinc oxide and TiO2 is the common semiconductors which are having some limitation is there because of that wide band gap, almost nearly 3.2, 3.25 electron volt band gap is there, both TiO2 and zinc oxide. So charge carrier recombination occurs within the nanoseconds. So it will be immediately recombination occurs. That is, recombination means when we pass the light, the valence band electron goes to conduction band, immediately it comes back to the valence band. So this is the recombination. So this is the ejection and recombination. So the recombination occurs within a nanosecond. So band edge absorption threshold does not allow the utilization of visible light. Then TiO2 absorbs only 4% of solar light spectrum. These are the drawbacks of TiO2. Similar to TiO2, this drawback of zinc oxide is also very low activity under visible light. Some of that preparation of in our lab TiO2 material and gold deposited and palladium, platinum, gold deposited TiO2 and titanium isopropoxide. We have to take titanium source and 2-propanol medium. We have to use 2-propanol and titanium isopropoxide. Then we have to mix together in a magnetic stirrer. We get a titanium alkoxide is there. Then it will be filtered and dried. We get a TiO2 powder is there. Then it will be calcined. We get a well-defined nano-sized TiO2 powder is there. The TiO2 synthesis having lot of methods are there. Some of that methods, hydrothermal methods is there. titanium isopropoxide and sodium hydroxide, where we have to put in a hydrothermal vessel, that is Teflon line and autoclave. We have placed in that two solution. We have maintained a temperature nearly 180 to 190 for 12 hours to 24 hours. We get a nano wires in that. So similarly, we have to prepare TiO2 is a raw material. Then the TiO2 can be deposited, photo deposited. This is our photoreactor, photo deposited by silver, palladium, platinum, and gold. So we have to add different desired concentration of silver nitrate and palladium chloride and platinum and gold. So we have to deposit the noble metal deposited TiO2. It can be effectively utilize the visible light. So ultimate aim, the TiO2 is only active in UV light. So we have to activate, we have to tune that material by absorbing the visible light. So we have abundance of visible light in that solar light. So nearly 40 to 50% of visible light is come from solar light. We have to utilize that visible light by using that modified TiO2 material. This is another one, sulfated TiO2. We have to add sulfuric acid for different desired concentration, very little amount of very low concentration of sulfuric acid we have to add. Then the sulfated anions can be deposited on TiO2. So another one, apart from TiO2, this is the zinc ferrate nanomaterial. Is a spinal material. It is very important anti-cancer activity material. Especially we have prepared and we have analyzed in the MCF7 breast cancer cell line. We have excellent activity in that zinc ferrate material. So we have to prepare ferric nitrate and zinc nitrate in the 2:1 ratio in the presence of 50 millimole of ammonium acetate under ultrasonic dispersion for 30 minutes. Then finally it will be hydrothermally treated with 180 degree for 12 hours. We get a zinc ferrate nanoparticles. Similarly, already I told that hydrothermally deposited noble metal, double TiO2 zinc ferrate. Already we have prepared a titanium isopropoxide and 2-propanol, and a desired concentration of zinc ferrate can be added to that solution. And noble metals, we have used noble metals which are having a highly costly materials. So we have to add very little amount, 0.5%, 1%, 1.5%, 2%. So we have to use only below 2% because the environmental work will be appreciated for low cost, for the utilization of low cost material only. So finally, it can be calcined hydrothermally, and the calcined we get a noble metal deposited TiO2 zinc ferrate. Another one material, this is cerium vanadate. We have to add ammonium ceric nitrate and ammonium vanadate in 70 ml of DNS water, prepared in 70 ml of DNS water. Then 10 ml of 0.1 m urea was added to the mixer. Urea is a fuel. For that, then that was stirred for an hour. Then it is transferred in a Teflon lined sealed stainless steel autoclave, kept at 180 degree for 12 hours. After that, we get a cerium vanadate precipitate was collected, washed with water and ethanol. Finally, it was dried at 80 degree for 8 hours. This is the absorption spectrum for methylene blue dye. Primary analysis, first A is that dye and solar light. There is no change in that. And dye cerium vanadate dot, we have nearly 19% of adsorption was taken at the surface of that cerium vanadate catalyst. And we have to carry out the reaction in the solar light. We have almost 85% of degradation was observed at the time of 90 minutes. So 85% of methylene blue is degraded. This is the XOD pattern of that cerium vanadate. It was well matched with JCPDS code number 720282, and this is the FTER spectra for that cerium vanadate. This 450 and 790 is the metal axis vibrations are present in that. This is 3300 is what stretching vibrations are there. Just a minute. Yeah. FSM images of cerium vanadate. We have rod-like materials. We have observed rod-like materials is there. We got hydrothermally treated cerium vanadate. Is the shape of that material is rod-like material. The color mapping of the cerium vanadate shows that the presence of the elements cerium, vanadium, and oxygen. And DRS, UV DRS. So we have to find out the band gap of that material. So 2.62 electron volt. So we know that below 3 band gap materials, it can be used for visible light. So 2.62, it's a visible light active material. EDAX is the elemental color mapping. Sorry, the X-ray elemental dispersion methods, and the corresponding element cerium, vanadium, and oxygen present in that analysis. And we have to perform that reaction in the solar light. First one is the catalyst loading. So we have to add minimum amount of the catalyst, 0.8 gram and 1 gram and 1.2 gram. Above 1.2 gram, the rate of degradation decreases. This is due to that the scavenging effect of that material, and excess of catalyst material will scatter that light also. So the optimum amount of that methylene blue degradation in that cerium vanadate material is 1.2 gram per liter. So this is our bench scale reaction in solar light. So you have to use that bench scale reaction. A simple aqua motor is there. So this is our burette stand. So we have to collect everything. This is our eutetic apparatus. Already we know that in our UG lab, eutetic apparatus, outer jacket is there. We can use beaker. We can use a long test tube. Anything. Next one, initial solution pH. In that reaction, at 7, pH 7 is the maximum degradation was observed. Almost 87% of degradation was observed at the time of 60 minutes. Dye concentration, when we increase the dye concentration from 1 into 10 to the minus 4, 2, 3, 4, 5. So we have to increase the dye concentration. The rate of degradation decreases. This is the after completion of the reaction. This is the bench scale reaction. So different pH of that reaction. Small blue is there. So pH 7 is completely degraded. It will show that just like water. I think this is the below 6 or above 7. I think so. Different pH analysis can be shown, and reusability. So we have used multiple runs of that catalyst. So it can be used for long term. So the fresh catalyst was used for fresh run. That is the first run. Another, then we have to dry, and we have to collect that all the materials. then we have to use another run. So we have to use up to 5 runs. All the runs we have, there is no significant change in efficiency. So the similar trend of that photocatalytic mechanism, when we pause the light, the valence band electron goes to conduction band. The conduction band electron can be react with the oxygen molecule to produce superoxide radical anion. These whole react with water molecule to produce hydroxy radical. The hydroxy radical and superoxide radical is a major source. This oxygen also react with water to produce hydroxy radical. This huge amount of hydroxy radical can be degrade the dye molecule. COD chemical oxygen demand. So almost 95% degradation was observed at the time of 120 minutes. Here we have compared that 90% of degradation was observed in UV light and 87% degradation was observed in solar light. So it is a coupled semiconductor, that is a nanocomposite, cerium 188 coupled with zinc oxide. So preparation of that material, so we have prepared zinc nitrate and oxalic acid in the concentration of 0.4 and 0.6 molar. These two material was prepared and it was stirred for 3 hours in a magnetic stirrer or mechanical stirrer. Then we have to add 20 weight percentage of cerium vanillate to the alcoholic medium. Then again we have to do the stirring process for again 3 hours. We get a white precipitate. Then it was filtered, dried. The dried sample was calcined for 6 hours. We get a cerium vanillate loaded zinc oxide. This is the primary analysis. This is a very important tool for that. Whether the catalyst, which catalyst is the give maximum efficiency. We have to find out that A is the dye in solar and B is the dye zinc oxide dot and C is the dye zinc oxide and solar light. First two, third one is D. Fourth one is D is the dye cerium vanillate, zinc oxide, solar into 10 weight percentage. So my student prepared 10, 15, 20, 25% of cerium vanillate loaded zinc oxide. So we have to check whether the optimum catalyst, whether the optimum loading of zinc oxide gave maximum efficiency of the RO4 degradation. That is reactive orange 4. We have it is a published paper in Environmental Science and Pollution Research, Springer Journal. Here 20 weight percentage of cerium vanillate zinc oxide in solar light have maximum efficiency. The G is the 20 weight percentage of cerium vanillate zinc oxide solar light have maximum efficiency. Here only zinc oxide in solar gave only 45 to 50% of 45% of 37, nearly 37% of degradation was observed. Yeah, characterization. Say FTIR, the OH stretching vibrations are observed nearly 3,448 to 3,419 centimeter for all the samples. First one is zinc oxide, second one is cerium vanillate only. This is zinc oxide and cerium vanillate. This 4 is the different weight percentage of cerium vanillate loaded zinc oxide. So it can be seen that FTIR spectrum of significant vibration observed in the range of 400 to 500, which can be assigned to the characteristic stretching vibration of ZNO vibration, that is metal oxygen vibration mode. Then 825 and 418 peaks were assigned to the stretching vibrations of VO and CUO vibrations. Another small band were observed in the sample at 3423 and 1633 and 1396 correspond to the bending vibration of H2O2, and C2F shows that the both zinc oxide and cerium ZNO and cerium O stretching vibrations are observed from 861 to 414 in centimeter. Hence, cerium vanadate loaded effectively on zinc oxide. Another one is XOD. So we have to very important tool. We have to find the nature of that crystalline nature of that material and size of that material also. And first one is zinc oxide, second one is cerium vanadate, and 3, 4, 5, that is C, D, E, F. All these are cerium vanadate loaded zinc oxide. So very little amount of that 101 and 200 planes are observed in that cerium vanadate loaded zinc oxide. So it is clearly shows that the first one, A, is the zinc oxide, is the corresponding planes 100 and 002, 101, 102, 110, and 103, and so on. These are the well matched with the JCPDS code number 36 1451 for the Woodside structure. And the characteristic peak of cerium vanadate at 2 theta value 18.1, 24.51, 32.12, and 32.61, 39.02. Which correspond to that planes can be well matched with the tetragonal structure of cerium vanadate, which having the corresponding JCPDS code number 720282. However, because of cerium vanadate exists in highly dispersed from in the zinc oxide host, or the amount of cerium vanadate is very small. So 28% is so beyond the detection of XRD. So cerium vanadate except a small diffraction peak at 23.97 and 28.61. So we have a different magnification of that cerium vanadate loaded zinc oxide. So we have a micro flakes like structures clearly shows that the zinc oxide nanostructures. These are the EDX analysis. So we have a corresponding elements, zinc, vanadium, cerium, and oxygen is confirmed. The corresponding color mapping to confirm the presence of elements of cerium vanadate zinc oxide was analyzed by the elemental color mapping. The different color areas indicate the cerium, vanadium, zinc, and oxygen enriched areas of the sample of cerium vanadate zinc oxide. This is the TEM analysis. The TEM analysis reveals that the hexagonal structures shows that the hexagonal Woodside structure shows that the material. So we have only 28% of cerium vanadate. So major part is zinc oxide. So we have shown maximum of hexagonal structures, and we have a particle size also nearly 27 nanometer was analyzed by histogram by using ImageJ software, and UV-DRS. The optical properties of cerium vanadate zinc oxide were explored by UV-DRS. So this is the DRS of zinc oxide and cerium vanadate zinc oxide catalyst displayed in that figure. Cerium vanadate zinc oxide shows a strong absorption in UV and visible light. So it will be a strong absorption in UV and visible region. So it will be a reduction in reflectance. It will be maximum absorption in the visible region. So there is a slight increase in the absorption in the visible region. This reveals that the cerium vanadate zinc oxide can be used as a solar light active semiconductor nanomaterial. So strong solar light absorption may lead to the increased generation of electron hole pairs, which enhances the photocatalytic activity of the catalyst. By using Kubalka-Monk plots for zinc oxide and cerium vanadate and different weight percentage of cerium vanadate zinc oxide shows that we get a different band gap energy. Zinc oxide having 3.16, cerium vanadate having 2.37, and different weight percentage 10, 15, 20, and 25 having 3.23, 3.22, and 3.22 and 3.21. electron volt for band gap energy. Next one, already we have discussed for that different parameters. This is the optimum pH is 7 and maximum degradation was achieved at 150 milligram of that catalyst in 50 ml. That is 3 gram for that in 1 liter. It can be used for higher concentration also. So we have to check the dye concentration. It can be used for multiple runs. All the runs, almost 97% degradation was observed. So some of that reduced graphene oxide based semiconductor photocatalysis. Now the graphene material is used for various applications. It's a very smart materials. So we have used for that photocatalytic purposes, zinc oxide RGO, TiO2 RGO, tin oxide RGO, and cadmium sulfide RGO, zinc sulfide RGO, and some metal phosphate RGO, such as zinc and cadmium phosphates RGO also we have prepared. So we have give cadmium phosphate RGO. This is the schematic preparation for that graphite powder and sodium nitrate and potassium permanganate. It's oxidation reaction in the presence of sulfuric acid. So this reaction is carried out very careful condition. So we have to add potassium permanganate gradually, slowly, with constant stirring in the ice cold bath. So we have to take a graphite powder and sodium nitrate and 92 ml of sulfuric acid. The whole apparatus is kept in an ice bath. Then we have to add very small amount, nearly 200 to 500 milligram of that KM104 we have to add. Then the oxidation process can be carried out inside that reaction vessel. Then it will be after that completion of that KM104 and 15 gram of KM104 we have to add. So after that completion of the 15 gram, so we have to add distilled water very carefully, very important. Then we have to add 30% of hydrogen peroxide. Then finally it will be refluxed, then filtered, refluxed for 2 days and filtered using 5-8% of HCl. We get a graphitic oxide. This graphitic oxide can be converted into graphene oxide. 1 gram of graphitic oxide is added to 500 ml of hydrogen water. In ultrasonically, it can be exfoliated in a bath ultrasonicator. After 1 hour, we get a light brown precipitate. So we get a graphene oxide is there. So it will be washed with ethanol, filtered and dried for 80 degrees for 1 hour. There is a preparation of RGO coated cadmium phosphate. Cadmium phosphate, just we have to give a symbol like CDP. Okay, equimolar amount of cadmium nitrate and disodium hydrogen phosphate is added in a magnetic stirrer for 1 hour. We get a cadmium phosphate. This precipitate was filtered, dried and calcined for 50 degrees for 12 hours. We get a calcium phosphate nanoparticle. This calcium phosphate nanoparticle can be coated with GO. So we have to add different weight percentage of GO is added to that calcium phosphate. Then the mixed suspension was irradiated with UV light in our photoreactor for 3 hours. We get a GO can be photoreduced to RGO in the composite. This is the primary analysis. Already we told that. So here the 29 weight percentage of cadmium, RGO loaded cadmium phosphate is the maximum activity. So we have to characterize that. Oh, this is the XRD characterization for that. So next one, the SIM analysis. So plate-like and sheet-like structures are observed in that SIM analysis. the corresponding EDS analysis is there. And UV-DRS analysis, we have a wide band gap, 4.95 electron volt is observed in cadmium phosphate. After immobilization of that in the cadmium RGO, we get 4.71. So the pH, the 7 pH is the maximum active pH. Why we have choose 7? Because industry discharge the effluent is a neutral. So we have to analyze the industrial effluent directly. So we don't adjust the acidity or basicity. So we have to we have to mineralize, we have to degrade purpose, we have to use that effluent directly. So we have to maintain the reaction condition pH 7. We have to tune the catalyst for pH 7. So long-term stability is there. So we have multiple runs. It can be used for that catalyst. Almost all the runs gave 95% degradation was observed. So this is the photocatalytic mechanism of that RGO, low-density zinc oxide. This is the cadmium phosphate semiconductor. So when we pass the light, this is the light. When we pass the light, the valence band electron goes to conduction band. The conduction band electrons are captured by the surface of RGO. So this RGO captured the electron. The electrons are transferred in that RGO layer. Then the presence of oxygen, we have provided oxygen. That is, we have to give oxygen like that. Yeah, aquamotor. This oxygen can be react with the electron to produce superoxide radical anion. This is a reduction process is carried out in that layer. So simultaneously, the gold reacts with the water molecule to produce hydroxy radical. So the hydroxy radical degrade the dye molecule. Some of the Fenton-like mechanism. Ajay sir, the time is there or not?
Yes, sir.
Continue, sir.
You can continue.
Okay, sir. Okay. So some more slides is there. Fenton reagent is a very, very simple one. It will be discovered. It was discovered in 1894. Fenton reagent was first reported by H.J.H. Fenton. Since 1990s, Fenton and photo-assisted Fenton reactions have been widely utilized in the degradation of aromatic organic compounds in the industrial wastewater. So it's a simple technique. In ferrous sulfate and hydrogen peroxide, we have to mix that. It will be a Fenton reagent. So we have to use that ferrous sulfate and hydrogen peroxide can be used as a catalyst. This is a homogeneous catalyst. Can be treated for that water treatment, but having a drawback is there. So we will see next slide. So the oxidation system based on Fenton reagent, hydrogen peroxide in the presence of ferrous ions or ferric ions has been used as a powerful source of oxidation radicals. So generation of hydroxy radicals are highly reactive or non-selective, such that able to decompose many organic compounds. So this is the usual Fenton reactions. Fe2 plus reacts with hydrogen peroxide to produce Fe3 plus and hydroxy radicals and hydroxide ion. Photofenton process is there. Fe2 plus reacts with hydrogen peroxide in the presence of light. It will also produce these same products. So the Fe3 plus reacts with the hydrogen peroxide and H-mu to reduce Fe2 plus and hydroperoxy radical and H plus ions. And H2O2 reacts with in the presence of light, it will be decomposed hydroxy radicals. So Fe3 plus in solutions reacts with water. Only Fe3 plus reacts with water in the presence of light. It will be photoreduced. Immediately it will be photoreduced to Fe2 plus and hydroxy radicals and H plus ions. Some of the drawbacks of photofenton process. So two major drawbacks. The range of pH for Fenton reaction is tight. That is pH is equal to 2 to 4. Only very narrow pH. It can be used only very narrow pH. And the acidification is more costly than the energy and accident is used in the Fenton reaction. Second one, the catalyst of ions cannot be separated because of Fe2 plus, that is ferrous sulfate, can be mixed with water or hydrogen peroxide. It will be immediately produced hydroxy radical and it will be oxidized to Fe3 plus. But it is a homogeneous homogeneous medium, so it cannot be separated. So it cannot be reused. So it may result in second pollution of the water, and removal of them at the end of the treatment will increase the cost of that treatment. So some of the advantages for the Fenton based catalyst: high photocatalytic activity, long-term stability, low cost, and no need much manpower, no sludge formation. It would be of considerable interest to investigate how the catalyst might perform at higher pH, that is nearer to neutral pH. Such pre-adjustment of wastewater would not be required. So some of that material, iron containing material, there is iron molybdenate. So we have to use ferric chloride and ammonium molybdenate. Then we have to these two materials having that different concentrations. We have to stir for 80 degree in a magnetic stirrer. We get a light green powder. Then the resulting green precipitate was adjusted at to neutral pH, almost near 7 to 8 pH by using sodium hydroxide solution. Then again we have to stir for 4 hours. Finally we have to filter and dry for 80 degree, and this material was calcined for 550 degree. We get a iron molybdenate material. It's a greenish colored material. This is also a Fenton-like material. It can be used as a Fenton-like material. So this is our bench scale material, bench scale reactions. Also, it's a long tube, can be used for the reactions. So zinc ferrate mechanism, already we have published in that Material Science and Applied Chemistry journal in 2017. Can be used only in visible light active material. Now we have used for a Fenton-like material. So this Fe3 plus can be converted to Fe2 plus. Again, it will be Fe3 plus, Fe2 plus, Fe3 plus, Fe2 plus throughout the reaction till the presence of hydrogen peroxide. The reaction is a cyclic process. So the Fe3 plus present in that zinc ferrate material, it can be converted to Fe3 plus and Fe2 plus by using hydrogen peroxide. It's a cyclic process to produce hydroxy radical. These hydroxy radicals are degraded molecules. It's a reactive orange dye. So after complete mineralization, this catalyst can be separated by magnetically. So it is a magnetic material. Next one. Yeah, this is another one. It's a published paper in Iranian Chemical Communication in 2018. It's a iron polyvanadate. It's a good catalyst. It's a two-way mechanism is there. So one is the iron, another one is vanadium. So it's having just like a synergetic mechanism is there. Oh, synergetic means one of that one man, for example, one man lift 50 kilos. Another man, one man lift 50 kilos. Another man lift 45 kilos. So both the mans lift the weight totally 110 or 150 kilos. Why? How it is possible? Both the man lift only 95 kilos. How it is possible? That is synergetic effect. So both the people lift that weight, it will give more efficiency. Here also, iron and vanadium give more efficient degradation, give more efficiently generate the hydroxy radicals. So it will fastly degrade the material. So one side, iron is a cyclic material, Fe2 plus, Fe3 plus, it will be react with the hydrogen peroxide to produce hydroxy radical. It also degrade the dye molecules. Another one, vanadium 5 plus and vanadium 3 plus, sorry, vanadium 5 plus and vanadium 4 plus also react with the hydrogen peroxide to produce hydroxy radical to degrade the dye molecules. So this is the mechanism for that. This is the lines or that supporting is there. Fe3 plus react with the hydrogen peroxide to produce Fe2 plus and hydroperoxy radical, and H plus. Fe2 plus react with the hydrogen peroxide to produce Fe3 plus and hydroxy radical and hydroxy ion. Similarly, vanadium 4 plus react with the hydrogen peroxide to oxidize vanadium 5 plus and hydroxy radical and hydroxy radical. These hydroxy radicals are very much important to degrade the dye molecule. Again, we have modified that Fe2V4O13 iron polyvanadate can be modified by graphene oxide. So in iron polyvanadate, having in 50 milligram of that catalyst can be take the time for that 60 minutes for complete mineralization. By adding graphene oxide, we have to complete the reaction within 30 minutes. This is also already published in that paper 2019 International Journal of Industrial Chemistry. So ferrignated, the iron polyvanadate can be prepared by ferrignated and ammonium vanadate. It was maintained at 80 degree. We get a yellow precipitate, then it was finally calcined for 500 degree for 6 hours. We get a iron polyvanadate. So we have to coat it with different graphene oxide 12, 17, 21, and 25 in the ethanol medium by solid state dispersion method. Finally, it was dried for 100 degree for 2 hours. We get a graphene oxide coated Fe2V4O13. This is the FTR spectrum for that prepared material, and this is the XOD spectrum of that pattern of that material, and UV-DRS. The band gap energy of that material is 2.21 electron volt, and graphene oxide loaded material having 2.19, so having a very less band gap energy, so it can be effectively utilized in visible light, so sunlight also. So HRSM, so a flaky like structure where the aggregation or interconnection appeared when Fe2V4O13 was thermally heated at 500 degree for 6 hours. The EDX analysis, TEM analysis is that we get here the composite having two-dimensional sheet structure. The Fe2V4O13 particles on the surface of the graphene sheet support. The TEM characterization suggests that a good interfacial contact formed between the Fe2V4O13 nanoparticle and the two-dimensional graphene sheet. Since the transfer process of charge carriers in graphene semiconductor nanocomposites is intimately related with the interfacial interaction between graphene and the semiconductor. This is the comparison of Fe2V4O13 and graphene oxide Fe2V4O13. So the amount of that is both are almost 0.6 gram per liter. Hydrogen peroxide almost to say 10 millimole, another one is 15 millimole. The time of that reaction timing is 60 minutes irradiation time. So at the only Fe2V4O13 have 99% degradation was observed at the time of 90 minutes. But in the case of graphene oxide loaded Fe2V4O13, 40 to 50 minutes, we have almost degradation was taken, was completed. Almost degradation, methyl orange degradation was completed at 40 to 50 minutes. But in the case of only Fe2V4O13, it will take 60 minutes. So long-term stability, all the runs gave almost above 98% degradation was observed. The two-way mechanism, this is the enhancement of that higher photocatalytic activity of GO-based Fe2V4O13 for the degradation of methyl orange. Presumably results from the following reasons. First, the graphene oxide improved the absorption of dye and H2O2 due to their lower surface area and oxygen containing functionalities on the surface the catalyst. Secondly, hydrogen peroxide can act as a efficient electron scavenger to form hydroxy radical on the surface of the graphene sheets, which not only enhances the acceleration ability, but also greatly reduces electronic accumulation on the surface of graphene sheets. Therefore, graphene oxide, if it is both in hybrid nanocomposites, exhibits enhanced photocatalytic activity under UV and solar light in the presence of hydrogen peroxides. This is the hydrogen peroxide up to 20 millimole. Beyond 20 millimole, what happens? This is my scalar. This is UV reactor is there. This is the visible reactor is there. He submitted thesis. He is awarded, and Dr. Gautami is there. This is the pilot plant reactor in our lab is there. So we have treated large amount of dieffluent in the presence of sunlight in the open terrace. Nearly 1,000 liters, 500 to 1,000 liters we have to treat it within 2 hours. After completion of that treatment, we have only water-like liquid is there. This is the bench scale reaction. So now I am at deputed to nearby government college. So I have fabricated that this type of reactions give that in our Mannargudi Government Arts College for MPhil scholars. This is the last 5 years publications, nearly 46 publications in last 5 years. And currently now we have published last 2 months. January we have published in Journal of Indian Chemical Society for the nano heterojunction for the TiO2 bismuth oxide nano heterojunction material. Another one is a lead removal from that multivariant optimization of lead extraction from wastewater. Is a chemical papers, is a Springer one. Another one is a molecular liquids, Journal of Molecular Liquids, recently published last 1 month back. This having an impact factor 6.185. It's a huge impact factor. After that long time, I got that I have published 5 only in solar light, solar energy material and solar cells in my PhD, doing PhD time. Now I have published in that in 6.165 in Journal of Molecular Liquids. Is my collaborators. She's my senior, PhD senior is there. He's a student. I am also a collaborator in that work. I have designed all this work in the this work are done in my lab. Acknowledgement, Dr. M. Swaminathan is my professor and research guide, well-wisher for us, and Dr. M. R. Ranganathan, emeritus professor, Bharadasan University, is also my well-wisher. Dr. B. Krishna Kumar is my junior. He is a postdoctorate fellow, University of Coimbra, Portugal. Now he is in Spain. Dr. G. Tirunarayanan is one of my collaborator, associate professor, Department of Chemistry, Annamalai University. Dr. T. Raja Chandrasekhar and Dr. S. Sugna, MR Government Arts College, Mannargudi, also my collaborators. PhD Watts, Dr. S. Rajastri, and Gautami also got PhD last few months back. Dr. Gautami and Mr. P. Subburaj, and my scholars, research scholars, Gunasundar, Jayasri, and Yasmin, Satyapriya, Sweta, Abhina, Prabha, and now 2 more scholars are working. Vignesh and Kuralnila working in under my guidance. Now I wish to acknowledge Annamalai University and the MR Government Arts College, Mannargudi. Last but not least, UGC major research project is a major source. The funding is very important. So we have to do all this part of that research work. We have fabricated different materials. So I have to acknowledge that UGC. So finally, rivers saved our heroes. It is a time we have saved rivers. First one is the Karnan movie is there. So Karnan in Mahabharat. So Karnan in his baby is floating on that like that. Yeah, one container is there. Is the second one is a Tamil movie is there. Talabudi, already you know that Rajinikanth is also that the river saved that in that childhood days. Already we know that yeah, Bahubali is there. The child is saved by the river. So it is the time we have to save the rivers. Thank you.
Thank you, sir, for sharing your profound knowledge with our students regarding preparation of nanoparticles and nanocomposites in detail, and how nanocomposites is useful to solve various problems related to environment. Definitely, sir, students have learned many things from your lecture that will help them to achieve new horizons. Once again, thank you very much, sir, for such a wonderful presentation. Now, I called upon Dr. G.B. Tripathi. Yes, sir.
Dr. Aparna, sorry for interruption. I have one question for Dr. Muthuvel, sir.
Yes, sir. Yes, sir.
Okay, sir. Okay, sir.
Yes, sir. Proceed.
Sir, actually, first, let me apprise because, as you said, Professor M. Swaminathan is a guru for you. At the same time, he is also guru for me also because just little bit story is there. When I started the literature survey of photocatalysis, because my work of research is also on photocatalysis. So when I had been at the Puducherry University for refresher course, and this in particularly in Maharashtra,
okay,
I don't find any wood to have the photoreactor. So I tried many times to just fabricate on my own base in the laboratory, but every attempt found to fail.
Okay, sir.
And when I had a meeting with the professor in Swaminathan in Puducherry University, then he directed me how one should proceed to have a photoreactor. Then one student of Professor Swaminathan was Mr. John. He used to fabricate this photoreactor, and he helped me a lot in. Sir, one query is that how one can confirm like the complete mineralization of the waste material when you convert any waste liquid, for example, dye stuff or the pollutant from any dye industry discharge in the water bodies. So how one could come to know that whether the waste has been completely mineralized by catalyst? So HPLC is there. You can go through HPLC so that you can have an idea about the complete mineralization of water.
Okay.
Am I right, sir?
So we have go to that TOC or COD. We have to find out the complete mineralization for that.
Yeah. The complete COD is one of the prior steps to have the vision or have to get the conclusion about whether the photocatalyst material has worked or not. But when we have to go for the complete mineralization of the waste material or the effluent which is discharged from the industry into the water bodies, or whether you have taken one sample and you have treated that sample with our photocatalyst which was synthesized, and then as far as color is concerned, many of the material they are going to mineralize the dye stuff or etc. any pollutant. But if you confirm whether the complete mineralization of the dye stuff has taken or not, so is there any way rather than HPLC? Because many paper which we gone through, the people has show the data of HPLC to show the mineralization, that is the waste is converted into CO2 and etc.
Okay, sir. So in our lab, we have to monitor that material in UV light, UV absorption spectrum only. We have to monitor. After that, we have to, after completion of that reaction, we have to design one catalyst and any one of the die. It will be, we have to use a different optimization. Then finally, we have to send the sample for TOC analysis. How much amount of total organic compound can be present in that. So we have to analyze for the TOC, and we have to simultaneously we have to do that COD also. Another one important tool for that dye molecule and pesticide molecule. So we have to use for GCMS, gas chromatography and mass spectrometry.
Gas chromatography.
Gas chromatography and mass spectrometry. We have to take that different interval of time. Then we have to extract that dye molecule by dichloromethane, and it will be completely extracted from without water molecule. Then we have to purge that GC machine. So we have to get that different spectrums are there. So we have to analyze different intermediates. Finally, we have to identify that completion of the reaction. So is it enough for the paper, sir? So we have also done that. I am not presented in GCMS also, but we have GCMS also.
Gas chromatography is found to be very effective and to confirm the complete mineralization.
Yes, sir. Effective and authentic proof.
Thank you very much, sir, for being with us.
It's a authentic proof for that complete mineralization format.
Okay.
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you very much.
Thank you, sir. We will collaborate in future.
You have delivered a very informative lecture.
Okay, sir. I am very happy, sir. I am very happy to see you, sir. Another one photocatalysis man. We will collaborate in future, sir.
Okay, thank you. We will meet once again in any conference. We will wish that we meet personally, not online. We can have a physical meet in future.
Sir, sure. Okay, sir.
Okay, Dr. Aparna, you can proceed.
Okay, sir. Okay. I call upon Dr. GB Tiwari, sir, Department of Chemistry, to propose vote of thanks. Dr. GB Tiwari, sir.
Thank you very much, madam. Am I audible?
Yes, you are very much audible.
Thank you, sir. So it is my privilege to propose the vote of thanks. I express my deep sense of gratitude to the very respected principal, Dr. Vikas Domne, sir, for constant encouragement and support in organizing this online guest lecture as a part of Science Day celebrations. Since Principal sir is not well, so he could not join here. I also express my gratitude to the eminent resource person, Dr. I. Muthuvel sir, from Department of Chemistry, Annamalai University, Tamil Nadu. Thank you very much, sir, for enlightening us with your words of wisdom on the topic nanocomposites for environmental remediation. Thank you, sir. I express my gratitude to Dr. D.I. Shahre, sir, Head Department of Physics, for delivering welcome address and also guiding us on this occasion. Thank you, sir. I am indebted to the coordinator IQAC, Dr. Karthik Panikar, sir, for their valuable support in organizing this program. Thank you, sir. I am grateful to Dr. Suman Deshpande, sir, coordinator, Parent-Teacher Association, for their support and also valuable guidance on this occasion. Thank you, sir. I also express my gratitude to Dr. Shyam Dafre, sir, coordinator, DBT Star College Scheme, for their support in organizing this program. Thank you, sir. I am thankful to Dr. Ajay Ghatole, sir, coordinator, Science Forum, in organizing this program and delivering the introductory remarks. Thank you, sir. I express my gratitude to all the heads of departments, teaching faculty members for their presence, constant motivation and support. Thank you. Last but not the least, I express my gratitude to all the students for their participation in this online guest lecture. Thank you, one and all. And with the kind permission of the chair, the program concludes here. Thank you.
Okay, thank you, sir.
Thank you, sir.
Okay, bye-bye, sir.
I'm very happy to see all. Thank you very much, sir, for giving the opportunity for that express my research topic. I would like to thank that chemistry professor, I don't know his name, and Ajay sir, and all the dignitaries present here.
All the
Thank
faculty
you.
members.
Thank you, sir.
Thank you, sir. Thank you. Thank you very much, sir.